So welcome back to the online classes. Today we are going to discuss about the radius, velocity and energy. Now radius of what? Radius of Bohr orbit. Velocity of electrons and energy of orbit where electron is residing. On the last day, we had already derived this particular form, the value of Rn, that is the nth Bohr orbit. The value was n square h square by 4 pi square m z e square. Here I would like to mention that what is the importance of this. This was the radius of nth Bohr orbit. So obviously, if the n value is 1 and z value is also is equal to 1, if we put these values, then the equation will be reduced. What we can do over here is, if you see, suppose we are talking about first Bohr orbit. If we are talking about first Bohr orbit, and that too for hydrogen atom, in that case R1, that is the first Bohr orbit, will be 1 square into h square divided by 4 pi square m e square, because z is already equal to 1. Further, if I put this value 1 square into, now h is 6.626 into 10 to the power minus 27. We are putting this value in the form of CGS unit, so it is arg second instead of writing joule second, divided by, so the square of it, by the way, square of it, divided by 4 into 3.14 square into mass of electron. If you can remember, it was 9.1 into 10 to the power minus 28 into, it is 4.8 into 10 to the power minus 10 square. And you can calculate it by yourself, the n value that you are going to get. I am not writing the unit over here anymore. Unit we can write at last. Radius, the unit will be in centimeter. So the value, pre-calculated value, is 0.53 into 10 to the power minus 8 centimeter. That means it is 0.53 Armstrong. This is how it is. So for a first, what is the outcome? What is the physical significance of this? For a first Bohr orbit of hydrogen atom, you see it's this very selective value. This value means at a particular distance only the radius actually is established, not anywhere. So this is the first thing. So what we have determined, the radius of first Bohr orbit of hydrogen atom. This is what we have calculated. So this is what we have calculated today. Now, after doing that, let us move on. Our next topic will be that we will find out the velocity. So let us find out the velocity of an electron revolving around. So for that I will keep this term only. So now we are going to calculate the velocity. Velocity of an electron in nth orbit. Let us see how it can be calculated. Now for velocity value, we had previously calculated that we know already mvr is equal to nh by 2 pi. So v we can write nh by 2 pi mr. This much we can easily write. Now, since we know the value of r for nth orbit, so I can put this value nh divided by 2 pi m into r value is n square h square. Here it is 4 pi square m z e square. This is how it looks like. Now if I cancel it out, let us see which are the terms which will cancel out. N will cancel out, this m will cancel out, 2 will cancel and make it 2, pi will cancel. So it becomes, see here, 2 pi z e square divided by nh, that is the value of Vn. So we have calculated the velocity of an electron, which is 2 pi z e square by nh. Next is, we will find out the ratio between the velocity at nth orbit and the velocity at first orbit. So next is the ratio of velocity, in bracket it is between nth orbit and first orbit. So velocity, if it is for nth orbit, the value is already known, 2 pi z e square by nh. And if it is for first orbit, v1, in that case it should be 2 pi z e square by 1 into h. So now if I remove this part and if I do Vn by V1, it should be 2 pi z e square by nh into 1 into h divided by 2 pi z e square. On cancelling, you will see this total part will be cancelled out. H and h will cancel out. It is 1 by n. So we are getting Vn by V1 is equal to 1 by n. Very, very important. The ratio we have obtained between the velocity of nth orbit and the velocity of first orbit. So the relationship will be Vn is equal to V1 by n. This is also important. So these are the mathematical outcomes which will help us to solve various type of numericals. Now let us see the ratio between the radius. So for that, again I need the required amount of radius value. So radius, as we know, next topic, first let me write down the topic. It is the ratio of nth orbit to first orbit. This ratio we are going to find out. In this particular case, suppose the ratio value is Rn is equal to n square h square by 4 pi square m z square mz e square. Now if it is R1, the same value will be 1 square h square by 4 pi square mz e square. What happens is Rn by R1 is equal to n square h square by 4 pi square mz e square into, here it is, if it is by R1, then obviously it will go above, so it will become 4 pi square mz e square divided by 1 square h square. As a result, what happens is everything will cancel out, leaving n square behind. So it becomes Rn is equal by R1 is equal to n square. Or further we can write Rn is equal to n square R1. So this will be the final value. So this is the situation. We have found out the ratio between the nth orbit and the first orbit. So what we have observed is we can not only calculate the ratio of the velocities between the two radius. Suppose this is the nucleus. There are two radiuses. One electron is moving around here, one electron is moving around here. We can find out the velocity of these two. If it is v2 and if it is v1, we can find it out. And we can find out the ratio between the radius also. Suppose it is Rn and if it is R1, we can find out the ratio between them also. You know, n value we can put from here itself directly. So these are the options that we are having. The next one is a little bit more complicated. The topic is energy of an electron rotating in, or you can write revolving in nth orbit. Let us find it out. Here two things. First is the total energy, or I can write like this: total energy is the combination of potential energy, or you can write first kinetic energy. Kinetic energy plus potential energy. Remember that suppose an electron is here. Suppose this is the nucleus. Here the electron is rotating. So because of this continuous rotation, there will be an energy, and because the electron is situated at a distance from the nucleus, that is R, because the electron is situated here, it will have some potential energy. So it will have both kind of energy: kinetic because of its continuous movement with a certain velocity, and the potential because of its position at a certain distance from the nucleus. Now we know this value already. It is half mv square plus. Now the calculation of potential energy is, I am writing it down directly. I will be explaining why it is so. It is minus ze square by r. I will be telling why it is so. Just a minute. Actually, we already know that the attraction force is ze square by r square, right? Between the electron and the nucleus. But the electron, here you need to understand, the electron can be anywhere. At a distance of anywhere, the electrons can reside. Electrons can reside here. Say it is an infinite distance. But the electron is held back onto this particular place. So to calculate how much is the exact energy, we will actually integrate. We will actually integrate this one from r is equal to infinity to r is equal to r, because this electron can be at infinite position and it can be kept over here only at a certain distance. We call it integration. In mathematics you are going to go through it in much more details. Don't worry, you do not have to write this at the time of examination. You have to remember this term only. I am just explaining the reason. The reason is electron can be anywhere. So to get the exact value at how much energy is actually present in that electron when it is present over here, we are calculating that the amount of energy required to get it from r is equal to infinity to r is equal to r. This is called the method of integration by z d square r square into dr. Why the dr is taken, why the integration is done, you will only understand that in calculus, not before that. Your physics and maths teacher will be explaining that to you. For the time being, I am just showing that it comes like this. So the answer will be minus zd square by r. Now, what is the formula of this integration? Again, that will be known only if the integration is discussed in mathematics. For the time being, I am just showing it can be calculated. The process and all, you need not to bother right now. Just the only thing that electrons can be anywhere at the infinite distance. It has to be dragged back onto this particular place because of the attraction force, and the electron is now present over here, and that is now we are calculating its potential energy. Now when we have done it, when the value we have got minus zd square by r, now what we can do is half m, now v square you remember it is zd square by mr, plus and minus will obviously be minus, it will become minus zd square by r. Now what happens, obviously this will cancel out, it will become half ze square by r minus zd square by r equal to 2r, so it becomes zd square minus 2z e square, so it is ultimately minus zd square by 2r. So we have calculated the total amount of energy as minus zd square by 2r, but the r value is already known. The value of r we are putting now. Remember the value of r is n square h square by 4 pi square mz e square. So we are putting this value of r over here now, and it becomes, if I write it here only, it becomes minus z e square by 2 into, here it is n square h square by 4 pi square mz e square. Now this will cancel out, it will become 2. Then what will be the answer? The answer will be here minus, here it becomes 2, right? So 2 m, or you can write 2 pi square m, z into z becomes z square e to the power 4 divided by n square h square. So this is the total value of the energy. So the energy value that we are getting for an electron revolving in the nth orbit is this, minus 2 pi square mz square e to the power 4 by n square h square. Remember, there is a negative sign. You can see this negative sign. What is the reason for this negative sign on the energy expression? The reason is that if an electron is present at infinite position, to keep it at nth orbit, the electron will actually lose a certain amount of energy and will become more stable. So gain the stability, the electron the present on at infinite distance must be having greater energy, but it is kept here, it is not at infinite distance. Because of its the attraction between them, it is coming over here to gain stability, and to gain stability it loses some amount of energy. To designate, to signify that loss of energy, we keep that negative sign. Again, we are just signifying the loss of energy. We are not measuring the loss of energy. So we are just signifying that the energy is lost. That is why the negative sign is used. So this is what I have to discuss today. We have discussed the radius, velocity and the energy of an electron rotating in nth orbit, and we have calculated the ratio between the nth and first orbit also. Carefully go through these derivations. It has to be practiced again and again. Remember here, the black part over here is completely different, okay? So accordingly.